So this is the CPM Chapter 1 Tools exam, version A. Okay, so number 1 asked us to, given the following function, state the equation of the graph and describe the transformations from the parent graph. Okay, so h of x we were given is x plus pi cubed minus 5. Okay, so part A, we're asked to state the equation of the parent graph. Well, we know that the parent graph is going to be, if we take away the shifts, right, and all the transformations, we're just left with y is equal to x, so we don't have that plus pi, and we don't have that minus 5. So the parent graph is just the cubic function, right? It's just x cubed. Okay, so let's go on to part B. Part B asks, describe the transformations from the parent graph. Okay, so we have to describe the transformations from the parent graph x cubed. So we know in the parentheses, in the argument, we know that plus pi means horizontal shift left. How many units? Pi units. Right? If you're not happy with saying pi units, you could say 3.14 units, right? Approximately 3.14 units. Okay? That 5 right there, minus 5, is outside of our function, so that's going to do a vertical shift down 5 units. All right? And that's it for number 1. Number 2. Number 2 says we're given f of x equals to 2x minus 5, and g of x is equal to square root of x plus 5. Okay? So part A asked us to find the composition g of f of x. Okay? So remember, when we're doing this, this is equal to g. Now, we ignore what's on the outside for now and just substitute f of x. So f of x is 2x minus 5. So this is just f of x, and the rest is the same. Okay? The next part is tricky though. We want to plug this whole thing as the argument, right, into g of x. So now instead of saying x plus 5 square root, we're going to say, right, instead of this, instead of x, now we have 2x minus 5. Okay, so this is it. This is all we do, and then we simplify. 2x minus 5 plus 5 is 2x plus 0, and that's square root of 2x. Okay, and that's all the composition of g of f of x is. Okay, part B. Part B asked us to find the inverse function of g, right? So here's where we have to think, and there's a hint, unwrap. So to wrap g, right, g of x, how was it created? Well, we started off with just x, right? And then we added 5. And then we took the square root. Okay? So now we have to remember this is how g was created. To unwrap it, we have to do the opposite in the opposite order. So we start with y is x again. What's the opposite of square root? Well, we know that's just squaring, right? What's the opposite of adding 5? Well, that's just subtracting 5. Okay? So then we go up. We're done. So that means the inverse function of g is this, x squared minus 5. Okay? And that's the process. Nothing more, nothing less. Okay. So now let's go on to number 3. Okay, number 3. We were given the graph f of x. Okay? And it looks just, okay, well, I don't have it, right? So I'm going to sketch it, right? And we have at -1, it goes down 2, and it goes all the way up to 3, 1, it goes like this. Right? You have it, I believe. Negative 4, 1, 2, 3, 4, 1. So here's another point. And then it's just like this. Okay, so this is the original function. Now we want to sketch negative f of x plus 2. Okay, so what is this going to look like? Well, we know the negative here reflects it across the x-axis. This is our x-axis, right? Reflect across x-axis. And this plus 2, we know it's going to shift vertically up 2 units. Okay, in which order does this happen in? Well, remember the order of operations, multiplication happens before addition. So we can do this in 2 stages. Okay, so first it's going to reflect across the x-axis. That means this point reflects here, right? This point stays there. This point reflects down here, right? So it's going like this, right? These points reflect here, right? This is just the reflection across, and it's like this. Okay, so in green is the reflection, and then it shifts up. It shifts up 2 units. So every point moves up 2 units. Okay, so this point moves up 2 units. This point moves up 2 units, right? So we're looking like the one in orange. This in green moves up 2 units, right? So it's back on the red, and it's just looking like that. So here in orange, I have the reflection and the shift up. Okay, so that's all I had to do for number 3. So let's go on to number 4. Number 4, we were given a triangle, right? Number 4, we had a triangle, and we were supposed to solve. Oops, let me draw it like you had it. Like this. This was 17. This is 15. This is 6. And this is x degrees, right? We're given 3 sides and no angles, and we wanted to just solve for x. Solve for x, right? The angle x. So what you had to notice here was you can label this A, B, C. Then this would be little b, little c, little a, right? All we want to do is solve for x, which is the same as here, angle c. Okay, so what we could do, we would need to use the law of cosines. So to solve for x, the law of cosines, remember that is just little c squared is equal to a squared plus b squared minus 2ab times cosine of angle c, right? And so we have little c, we have little a, little b, little a, little b. We just want to solve for big C, okay? Because big C is actually equals our x, okay? So I don't even need to plug in anything. I'm just going to solve for big C. So minus a squared from both sides and minus b squared. So when I do that, these are canceling on this side of the equation. I'm just left with negative 2ab times cosine angle C. And then on the left, I have c squared minus a squared minus b squared. Okay, then I divide both sides by negative 2ab. Remember, I can't divide by cosine because cosine is wrapping angle C, right? So then I get c squared minus a squared minus b squared divided by negative 2ab is equal to cosine of angle C. Okay, so how do I unwrap cosine? Well, with the inverse cosine. If I do it to that side, I must do it to the entire left side. So now this cancels the cosine, and I'm left with angle C, which is equal to x, is equal to cosine, no, the inverse cosine of c squared minus a squared minus b squared, all over negative 2ab. Okay? So now what do? Now I just plug it in my calculator. So I know x now is equal to the inverse cosine, right, of c squared. Well, what was my c squared? I could just look at my triangle. 17 squared minus a squared is 15 squared minus b squared is 6 squared divided by negative, don't forget the negative, some people did, negative 2 times a times b. Okay? So you plug this in your calculator and you get the answer. Okay? So let's go ahead and do that. Let me turn on my calculator. To plug in the inverse cosine, remember it's right here in yellow, so I have to do second cosine to get it. I want to put this all in the numerator, so I have to put a parentheses around that. So 17 squared minus 15 squared minus 6 squared. Close the parentheses for the numerator, divided by, open the denominator parentheses, negative 2 times 15 times 6. Close my parentheses. Make sure my mode is, okay, degrees. Enter, and I get approximately 98.9, round that up to 5 degrees. So x is approximately 98.95 degrees. Okay? And I'm done with number 4. Okay, so now let's move on to number 5. Number 5, we are given two triangles and we want to find the special angle, right? Okay, so one of the triangles, not triangles, we're given two circles, excuse me, and we want to find the special angle. So these are two unit circles. Here's this one, it's like this. Oh, I cannot draw with this pad right here. Okay, so here it is, and it's starting this way. Okay, so this is what we're given. So since this is a special angle, we have to notice what? We have to notice that these quadrants are either broken up into 2 or 3. Well, this is definitely not half, right? Because half would be in the middle, so this means it's broken up into 3 pieces. Okay, if I can draw it well, it's drawn better on the test, of course. Okay, so 3 pieces. And we know if we split them into 3 pieces, each one of those pieces is going to be pi over 6, right? Pi over 6 radians, right? And if we're going in this direction, we know it's going to be negative, right? Since we're going clockwise, it's negative. So we start here. Let me get another color. We start here, right? I'm just going to trace it. This is going to be negative 1 pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6, negative 6 pi over 6, negative 7 pi over 6, done. So that is just negative 7 pi over 6, and that is in radians, and I'm done. Okay? So now let's go on to 5b. 5b, we had a different circle, or the same circle but a different angle. Okay? This time it was split right in the middle, right, of quadrant 3. And it started here going this way, so we know it's positive this time, right? Because going counterclockwise is a positive angle. Okay, so down the middle means that we cut all these in half, right? And each one of these is pi over 4. So let me start here, going in the counterclockwise direction, starting at 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and done. So this is 5 pi over 4 radians, and done. That's 5b. Okay? So 6, we were given two different angle measures. A was to convert 235, and that symbol means degrees into radians. So we have to remember we can multiply by a ratio that cancels out the degrees and gets radians. So that means radians has to be in the numerator, degrees in the denominator. So we know that 360 degrees equals 2 pi radians, or 180 degrees equals pi radians. Okay? So radians in the top, I'm going to choose this one to use. Okay, so radians in top, degrees in the denominator. Remember, this is over 1. So then you just multiply across. This is 235 now. Degrees cancel. Pi over 180 radians. So just simplify that, right? Simplifying that, you get 47 pi over 36 radians. Okay? Or you could have plugged in your calculator, approximately 4.0152 radians. Either one of these is the same, right? This is just approximate after you plug in the calculator. Okay. So this was part A. 6B. 6B, we were given 3.2 radians. Okay, so we want to convert this to degrees. This is not 3.2 pi radians. Some people thought there was a pi there, but this is not. It's just 3.2. So to cancel this, we want radians in the denominator and degrees in the numerator. So these cancel out when you multiply. Okay, so we know pi radians is equal to 180 degrees. So we just multiply across. 3.2 times 180, 1 times pi. So 3.2 times 180 is 576. 1 times pi is pi, and this is degrees. You could plug that in your calculator. You would have got 183.346 degrees. So either one of these is the same, okay? And you'd be done with the part number 6. Number 7 was pulled directly from the quiz from section 1.4. So I'm not going to go over that again because that's exactly the same, no change at all. So this ends the review of Chapter 1, Tools Exam, Version A.